Hello everyone. So topic for today is gesture to text neural network for space writing. So space writing basically refers to the idea of writing the character in free space by movement of hand, palm and fingers or using any devices like pen. In this project, we use generic web camera to recognize isolated characters that are scripted in space with neural network approach, and space scripting is performed using circular-like objects that act as marker of fixed color in front of the camera. The color of the in front of the camera is based on segmentation and it is applied to identify the center and trace its trajectory, which deforms and forms a character structure. The recognition is carried out by multi-layer perception and convolution neural network and is basically doing question recognition in computer interface for online computers to capture and recognize human gestures as commands. A gesture can be any physical movement like pointing a finger or head to toe pinch, or in some cases, it can also include voice or whatever commands. So basically, these moments in space or sound generally replace the tapping on touch screen or keep passing on as computer on keyboard data stream. However, motion themselves are not communicating enough to input text for motion-based control systems. The idea of using fingers or hand movements to scratch the letters or number in free space is standard. The aim of our project is to use this sort of gesture recognition that uses motions to represent characters and digits written in space. And we will investigate multiple algorithms publicly, and we are detecting the ultimate goal of space writing recognition. It includes lowercase, uppercase, or different stakeholders. In short, this variation will be the result of different scenario, like which needs extra recording to be monitored. We will verify our technique performance against all of the standard arts methods on large margin for data sets like user independent or non-independent. And now we'll discuss more about how we created an approach for the project, and delivery evaluation methods will be in detail. So in this approach, we used a generic web camera embedded in the laptop or any other monitor devices, thus avoiding the additional sensor to reduce the cost. The cost of absence in-depth information that is availed with special centers make it a bit difficult to process. The first one we use here is object segmentation in writing. So it is basically a color-based segmentation of hand or finger, which is difficult due to variable skin tones. Hence, a simplified approach of segmenting an object of uniformly distributed color. Blue color is object is applied and act as writing tip in a project for this. Input frame is converted to HSU, like hue saturation and value frame. So next we use is identification of writing object center. So this is after the segmentation of the binary image is obtained, for which the contours are calculated. We use finger trajectory deduction here. On a two-dimensional plane, trajectory tracking and projection are performed. Space writing is continuous path motions like discontinuous breakpoints. Enclosing the market area also moves along with the market that continuously changes the coordination of the center. This project is going to deliver such a solution that over the maximum errors and detect the sensor by using generic web camera. The lack of depth information available with the specific sensors make the processing of data and text complex. So all the difficulties image analysis is used to divide the writing devices such as the trajectory lines of the two-dimensional computer strokes and neural networks can be used to write in space. The first layer are the future extraction layers consisting of conventional layers followed by one max 4 layer with a pooling size of 2 by 2 matrix, and a convolution laser has a kernel size of 3 and 32. A kernel size of 3 and 32 or the 64 filters respectively. Second is like multiplayer perception network has four fully connected layers, each having 7, 8, 4, 5, and 1, 2, 5 neurons respectively. So we use MNIST dataset for training and testing purposes. So it is basically a handwritten digital collection. So everything is drawn on canvas, and when we press the detect button, the canvas acts as image, and this image is compared with the MNIST dataset and checks for the digit that is matched, and the output will be given here. So in this project, we use multiple libraries and programming language Python, and libraries like Keras Model Collections, NumPy, OpenCV, and others are used. So the next coding part will be continued by the teammate Krisha.
Hello, my name is Krisha Patel, and now I am explaining our code of our project. So, in this code, we will use the camera. So, that's why I stop my camera here and I share my screen. So, in this code, we use the MediaPipe, NumPy, collection, and TensorFlow as a library, as well as we use the MNIST dataset for our testing and training purposes. This set is typically like the collection of the handwritten digits. Here we use that data set for the comparing our canvas image with that data set, and we will get the information like output. So in this code, here we use the function to handle button click events. Then we another function which help to create buttons of color buttons like blue and green. Then we try to open the webcam. Then we try to create the canvas. Then initialize the finger trajectory points. Then after, so basically the steps of our algorithm is first we create the canvas. Then after we load the MNIST dataset. Then after loading that, our webcam is open, camera is open, and it's tried to detect our finger. And if we move anything from by using our finger, then a corresponding action will be print on the canvas. And when we click on the detect button, that canvas store as an image and it will compare with the MNIST data set. And after comparing that, we will give you the output. So now I am explaining the practical output. So here it's tried to open the camera and then it's open the canvas. So first of all, it's create the canvas. Now loading the data set. After complete this loading, the camera will be open. So now camera is open and now I am trying to detect any digit by using my finger. So now I am trying to draw the fifth 5. So when I click on detect button, it will give you the output as a 5. Here, like when I click on erase, everything will be erased. Even if I want to change the color like blue, then I click on the blue button and then I will try to again draw fifth. It will give it output 5. Even if I want to change the color green, then I click on the green. So everything is like draw on green color. and I click on erase, and everything will be erased. So basically, this project is very helpful for the person who are not able to write down anything by the using a pen or pencil. So that time they can use that finger as a tool, and they can like write down anything in the space. So we can detect that motion on the canvas, and then we can compare with our data set, and we will give it the output. I know sometimes it's not give the proper output, but we can at least detect that what he want to explain it. So this project is very helpful for that person, not only for that person, but in the many another occasion also it will be useful. So that is our project. Anything, thank you so much.